So let's do this.
Okay.
Okay. So given a 90% confidence interval of 45 to 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? So
How about we are 90% confident that the true mean heart rate is between 45 and 105?
yes. What is that?
Okay.
All right. Then question 3. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go non-stimulus in males from that of females. Researchers randomly selected 20 females, 15 males. Go, non-go stimulus required the student to respond to a particular stimulus, then respond to another stimulus. The researchers decide to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval will reliably create QQ plots, both in this approximately. Are the requirements for constructing a confidence interval satisfied? Why or why not? So so you have to have a distribution sample, and then not a distribution sample. Distribution means so yes, right?
Yeah, so you have to have a distribution of the mean sample, and it has to be normal.
So it would be yes, distribution of the mean of samples normal since the data has been determined to be normal.
Yeah, I like that one.
Okay.
All right. Question 4. Of the 4 types of confidence intervals below, which one is appropriate for this experiment? Confidence interval for the difference of means using independent samples?
Yeah. Confidence interval for the difference of means using independent samples. Right. Right, Neil? I don't think she got that.
She did. She's still frozen on mine and just
I've never seen the Matrix, y'all.
Oh man.
Mimi.
Take the red pill or the blue pill?
Okay, so let's see here. Question 5.
So researchers are interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval of the mean savings account balance of bank customers is found to be $34,002.08, $4,142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? So I think it's obtain the balance of 90 bank customers rather than 30.
Yeah, because a higher sample size lowers it, right?
Yeah.
No. Yeah. I'm thinking right. Okay. Okay. When do we jump into? Is this when we jump into SPSS?
Yeah, this is when you have to actually start calculating stuff. So.
Okay. All right. So, factory makes propeller, drive shafts for ships. A quality insurance engineer at the factory needs to estimate the true mean lengths of the shifts. She randomly selects 4 drive shafts made from the factory, measure their lengths, and find the sample mean to be 1,000 millimeters. Lengths are known to fall. Standard deviation is 2 millimeters. Calculate an 95% confidence interval for the true mean length. Okay. So, here's my equation. Uh-oh.
equation, would you use m equals z times the deviation divided by square root of n?
Where? Yeah, that is right. Where's my math?
Okay.
Okay. Okay. Sarah, you've already done this one, right? Have you already
We'll
done this
see
one?
if I get it right or not.
So, the heck? What is that? Okay. So you take 1.96 times 2 divided by 1,000, correct?
For the margin of error?
Yeah. Yeah, right. Okay.
Divided by square root is the sample size.
Yeah.
Oh, by the square root of the sample size. Okay. Okay. Lyle, what did you get for 6?
I'm sorry?
What did you get for 6?
For 6,
Uh-huh.
I get negative 1.96.
How'd you get a negative, Lyle?
Yeah.
Because I get a positive 1.96.
If you take this earlier, so I'll do it again.
What did you get, Cameron?
I got positive 1.96.
I could have just keyed it in wrong. No, I come up with negative 1.96. Because if you take the lower and you subtract the upper and then divide by 2, you get
Okay.
come up with negative 1.96
Okay.
for the margin.
96 or the 4. Okay.
Sorry. You're totally breaking up, Sarah.
Oh, sorry. Can you hear me at all?
Yeah, now I can.
Okay, good. Well, just because I did the formula of like 1.96 times 2 divided by the square root of 4, so I think that's why ours is positive.
Positive.
Do we have to square? I mean,
Uh,
square our answer for the margin of error, right? So isn't it
no,
1.9?
that one's for the sample size.
Oh.
The sample size is the one that you square.
Okay.
Yeah.
I get
So.
positive 1.96.
Okay, I'll go with that.
I mean, I'll take the fall. If it's a negative, then
Well, we get
then
2
we
choices,
know.
so it's either going to be a positive or a negative, but it's going to be one of those. So.
Yeah. So then question 7, you input the lower bound, so I get 998.04.
0.
Huh?
Yeah, 040.
Yeah.
And then for the upper, you get 1001.960 or 96.
Yeah.
Mm-hmm. Okay. And then for 9, you need time to calculate that.
Standard weight. No.
N times.
So this is the one that you would square.
Yeah.
Okay. Okay, just to make sure I'm setting it up right. You set it up 1.96 times 0.01 over margin of error for 1.96 and then you square it.
Mm-hmm.
Yeah.
Yeah. I like that.
Right. Okay, so I got 0.001. No.
I didn't get that.
What did you get, Sarah?
No, 8,460.
Yeah, 38,416.
Oh man, I
Yay!
was really jacked something up here. All right. What am I doing wrong here? 1.96 times 0.01, right? And then you divide it by 1.96, which gives you 0.01.
No, you divide by 0.001.
Yeah, 0.000.
Yeah, because that's the margin of error.
Yeah.
Yeah.
Yeah, divide by the margin of error.
I thought we were using the margin of error for the other one. Okay, yeah. So 384.16. Okay. All right. So, question. Are we good to go to question 10?
Mm-hmm.
Yeah, I'm ready.
Okay, so the mean are view of the several thousand apartments in the developments is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments and test their suspicion. The appropriate, null, and alternative hypothesis or it is HO equals 1,250. HI equals 1,250. Is it the second one?
So it's the equals to 1250. What's the second part?
Less than or greater than 1,250?
Our answer's all randomized? Okay, no. So the answer is the first part on mine is all the hypothesis is 12,050.
Yeah.
The second part is less than 1250. So
Yeah, for the answer too is that the alternative is that less than 1250, because in the question it talks about how
they think
a tenant group thinks that the apartments are
smaller.
than advertised.
Yeah.
So alligator mouth away.
Yeah.
All right. Question 11. In a statistical test of hypotheses, we say we reject the null hypothesis with a level of significance A if the p-value is larger than A, right?
P-value less than A.
Less than A. I'm going to do great on this test.
Killing it, killing it.
Yeah.
Just make sure the wife is awake when you do it.
Okay.
Just read the questions carefully because I'm telling you they are designed to confuse.
Okay, here we go.
Group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings, maybe because some are smaller than others, I don't know. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data from each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis to test an hypothesis test to answer their question?
Yeah, this is the one that I didn't know.
Okay.
So to do an ANOVA test, you have to have the standard deviations, right?
Do you?
Because doesn't it pump out those QQ plots too? Well, I guess that's a whole different test, huh? That's not another test.
So they have to be random samples. They have to, you have to have multiple different. So there's 4 different samples. They have to be bell-shaped. So the bell-shape means that the QQ plots are going to be in line, right?
Mm-hmm.
And there's going to be no outliers with the sample variances. So the answer is yes.
Yes.
It is enough that the data for each building are bell-shaped with no outliers, and the sample variances are nearly equal.
Okay, perfect.
How many questions are there? Oh, 32! A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time of the population of all patients with this particular type of cancer. The researcher has... What do you think?
Hypothesis is true, but they rejected it.
So she incorrectly used an 0.05 significant test when she should have commuted the p-value?
So what do you think? What do you think, Sarah?
Can you guys hear me?
Yep.
Okay, I think she committed a type 1 error.
Yeah, she did. Whenever they start like circumventing data and they just take a couple of early samples and, oh yeah, well 2 or 3 come up and we're not going to continue with the study or anything like that, or just jump to a result, especially when they're talking about medical stuff right there, that's a type 1 error. So just like kind of keep that in mind. They're not running the full run of their test and everything.
Okay. Question 14. If the level of significance of significant is very small, thereby making the probability of committing one error very small, what happens to the probability of committing a type 2 error? in the probability of committing a type 1 error. We also reduce the probability of committing a type 2 error. All right.
You're tired. No.
I think this was the lesson this was the week that me and Stacy were gone for both these group meetings. And I sucked it up on studying.
Okay.
Oh, yeah.
Mm-hmm.
So, whenever you reduce the probability of one error, it increases the probability of the other. They're like tied together, right? So if they're going to reduce the probability of committing a type 1, then they're probably going to increase a type 2.
Okay.
It's going to happen.
Yeah.
2. Okay.
And in the errors, type 1 is way worse than a type 2. So you don't want to commit a type 1 error.
Okay.
That's typically like in medical stuff. It's like gross negligence and
All right. Keep kicking along here. All right. So 15. The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams and a known standard deviation. Brand advertises the mean nicotine content, but measurements on a random with sample mean of 1.53. This evidence that the mean content is actually higher than advertised. To answer this, yes.
okay, which one?
So I'm saying what makes our belly to reject. Then I watch your head shake now every time.
No. So if you look at it, so they're saying that their cigarettes have a nicotine of 1.5, right? They took a sample of 100 cigarettes, and the sample mean of those comes out at 1.53. So that's higher by 0.03 than what they're advertising the nicotine is. So their hypothesis is wrong.
Okay.
So we would reject their hypothesis.
Yeah.
Yeah.
Sometimes it's just in looking at the problem and interpreting it and saying, hey, wait a second here, we're reading it right, looking at exactly the facts that they're presenting, and then, okay, wait. If they do, they did a good-sized sample. It's over 30, 100 cigarettes is a good sample. They come up with a sample. Yeah, you would reject their hypothesis.
Okay.
Okay, 16. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct plural or singular? What test?
Would it be independent samples?
Yeah, because it's for each group.
Yeah.
Okay.
We don't have any.
I can read 17 if my
Cool.
voice isn't too weird. Is it weird?
Yeah.
An educational economic support system. Be nice. Brothers and sisters raised in the same home. She decides to use only brother-sister sibling order. Should she use a hypothesis test based on independent or dependent sampling?
Okay. We just read along.
Great, that's fine. Reading.
Okay.
Okay. So the question is, it's two answers, independent or dependent, right? And then what's the catch, depending upon which one? That's all they're asking.
So the catch, I think, is that, like, I mean, they're separate. So you would use independent sampling because the brother and sister are younger people, right? So let's hear. Knowing the brothers included in the study tells me nothing about which the sisters are included in the study.
So you think it's independent sampling? What do you think, Fair?
Or Cameron.
Huh?
I think Sarah's like a full minute behind us.
Guys.
As part of the matrix, you should be able to get all of these answers, right?
All right.
Okay, so it's I believe through this experience that it's actually dependent sampling.
Dependent.
It's dependent sampling.
Okay.
Because they say, furthermore, she decides to use only brother-sister pairs. So that means they're paired together. It's not independent. They're dependent upon each other. And then that you have to select a brother so as to compare his academic achievement to his sister. You must include the sister in the study.
Oh, okay. That makes sense. So when would you use independent sampling?
When it has nothing to do with the brother-sister pairs.
Okay. Okay. All right. So now we're jumping into SPSS, right?
Sure.
Okay. So resolved organic.
She's done with us.
She leave.
I'm back.
Okay. Okay, so dissolved organic carbon right there. Okay, okay. So, analyze statistics. Okay, so what is the first question? So, of the 4 types of confidence intervals listed below, which one is appropriate for this situation? Confidence interval for you. How do you know that one? With just the information given in SPSS.
That's one you just have to know from reading in the book. The SPSS information is going to come into 19, 20, 21. And then you're going to answer 22 is also going to be another one.
Just book. Because the SPSS stuff isn't bad. It's actually really nice. I wish everything was in SPSS.
Amen.
Okay. So for 18, samples. So he's collecting random soil samples. The measurements are recorded. So the other one was independent. So I'm assuming they're random. So, and we don't have the standard deviation. Is it the ones with the confidence interval for the mean when the standard deviation is unknown?
I like that. Yeah, that's the one.
Okay, and then for 19, margin, 95% margin of error is, where is it? I have the upper bound and the lower bound. 95 confidence intervals. So the 95% confidence interval, 13.192.
The margin of error.
That's not right. That's the mean. Where the Because you do analyze, descriptive statistics, and then just put 95% in, right? And click all the little things.
So the way that I calculate the margin of error is you take the lower bound, subtract the upper bound, and then divide that by 2.
That's a great idea. So 15. So did you get 15.217 for the?
I have the lower. I have 11.168.
Okay, yeah.
For the upper, I have 15.217.
Okay.
So that's 20 and 21.
And then for the margin of error, 2.024.
2.025.
Oh, yeah.
Is that what you have there?
Yeah. Rounding it, yeah. Okay, so the lower bound. 11. Okay, so now for 22. Sarah. Sarah, you good on those?
Yeah.
Perfect wiggles.
Okay.
This is another one that's just asking you what type of information you have or don't have. So.
Hi, Toria. Stu, how much questions do you have? I'm in a meeting, bud. Can you close the door?
I should have set up all these SPSS things beforehand so I didn't have to pull them out one by one.
It's all good.
This gives me a break. Torturing people. So.
Okay. Okay, here we go. So, analyze. Oh. Which one is the appropriate time? So this is the same thing as the one before. So we know the. No, that's not right.
I can't.
For 22.
I don't know what it is for 22.
Sarah?
I have that it's the confidence interval for the difference of means using independent samples because New York and Los Angeles are two different places.
Mm-hmm.
And so it's trying to compare, and they're two different samples. And they don't really depend on each other for data, so that's why I picked that one.
Yeah.
Okay. Okay, and then for lower bound. Statistics. Okay, so for lower bound, I got 40,130.
You got what?
40,139.66 for the prices, right?
Well, did you do like the difference thing? Did you go into the SPSS and do the what's it called? It's in my head, but I can't think of it. Lyle. What's the
Recode?
No, it's the one where you go in and make the difference between the two. make like a different column. Don't look at me like I'm crazy, Lyle. I'm not crazy.
Making things up now, I swear.
No, I'm not. I'm not making them up.
I know what you're talking about, but I don't know what you're talking about.
Okay, well, hold on. I will explain it.
Isn't it?
I can tell you. What did you come up with, Sarah?
I had negative
423.
Yeah. Okay, so you go to transform.
Yeah.
Yeah, and use there it is. You say compute variable, and then it'll pull it up, and then you take
Do you see my hair?
Oh wait, do you have to go encode it? Is that how it works? How did I do this?
Compute the variable for the price.
Which do you? How did I do it? I don't remember. Let's look. Okay, so you make a recode for
LA versus.
yeah. So you make a recode for the city, and then you analyze it from there.
And then you do explore descriptive statistics.
Yes, that one.
Code, city.
And then you should get an upper and a lower bound.
Code, add new name, okay. And we go back. Statistics. Statistics, explore price. Mid data. Factor. Statistics.
Okay, sure.
Wait, I want to do that thing again. It looks like a graph. Do it again.
All right.
You want to do something else now? Look how long my hair is. Yeah, you need to. Want to see how long my hair is? And look, I made a racetrack. Look.
Okay. That's it's. I got the same 23, but I'm just gonna put down what you guys got, and I'm gonna go. I'm not gonna waste the day because I'm a slacker.
Okay. So then for the upper bound, you should have 5,417.
0.256, right, Lyle?
Okay. What did you guys get for 23?
Yeah, look how long my hair is.
Negative something.
Negative 423.158.
Okay. I'm sorry. I'm like useless today. Like, I don't know what I'm doing.
That's okay. We're just glad you're in our group.
Okay. Okay.
And then 24. And then 25, you know.
For 25, what is the correct hypothesis test for this situation? I said ANOVA.
Yeah.
Because they're measuring more than 2.
Yep. Anytime more than 2.
Okay.
And then I have 7.9,
It's 0.
and then 0.002.
Mhm.
Where are you going?
And then for 28, I'll say, which of the following best expresses the conclusion of this test? I say there is insufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups.
Wouldn't it be there is sufficient? Because if the p-value is 0.002, that's lower than 0.05. Is that, am I right, or am I just making stuff up? Okay, so I picked the whatever one second from the bottom that says there is sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups.
Mommy, look at my hair.
Direct flights.
I said that when it asked what is the correct hypothesis test for the situation, I said dependent samples test. Because you have like a before, you know, like the 90-day flight, and then you have the 14-day before flight. And so you're looking at like before and after kind of. And they're related because they're the same flight, just at different, prices.
Yeah, changes the parameter. 30. I have 1.685.
Mm-hmm.
Value, I have 0.096. And this is the last one.
Yeah. For number 32, I have there is insufficient evidence to conclude that there is a difference in the mean cost of tickets purchased 14 days in advance compared to 90 days in advance.
Answer.
Oh, yeah, because it's 0.10, huh?
Yeah. So I say there is sufficient evidence to conclude that there is a difference in the mean cost of tickets purchased 14 days in advance compared to 90 days in advance.
That's right. Okay. I got tripped up by that. 0.10. Rude.
Yep.
Okay. Well, I'm going to submit it.
All right. You where the torture is.
Let's see. It says we missed. Which one did we miss? Where did it go? I missed question 6. The margin of error.
Is that the one we said was positive?
Yeah. So Lyle, you should try it and see if the negative is the correct.
And that's the only one that we missed?
I think. Hold on, let me just see. Scroll through all 32 questions. Question 19, we also missed. Determine margin of error.
That's probably also negative too.
Probably. That's weird. That's it. Those are the only 2.
Yeah, they're probably both negative.
Do you want to see if they are?
Yeah, I'm going to check it right now.
Did you